Gibson here. Today we're going to look at the next lesson in rational functions, and this is all about working with rational expressions. Let's look at our objectives here. So first, what does it mean to simplify a rational expression? And then once we understand that, we can look at multiplying and dividing rational expressions. So let's go ahead and jump in and talk about what does it mean to simplify a rational expression. So a rational expression is in its simplest form when its numerator and denominator are polynomials that have no common divisors, right? So the key here is no common divisors. Let's get my highlighter going here. There we go. So no common divisors. Now, what do we mean by common divisors? Well, let's look at some examples here, okay? So here is a rational expression, right? Remember, a rational expression is just simply anything that can be written as a ratio or a fraction. And typically the ones we'll be working with will have variables in both the numerator and the denominator. So here's one, x divided by x minus 1. So are there any common divisors? In other words, are there something we can divide out of both the numerator and the denominator? Now, you might be tempted to say, oh, we could divide out the x or cancel the x, but the x in the bottom is not a factor, right? It's not x times something, it's x minus 1, part of an expression. So nothing to simplify here. This would be simplest form. Let's look at this one, 2 over x squared plus 3. Again, there's nothing that we can divide out of both the numerator and the denominator, right? We would have to have a factor of 2 in the denominator to be able to divide out the 2. Now let's look at some examples that are not in simplest form. Here's x divided by x squared. So in this case, right, we could divide out a x out of both the numerator and the denominator, right? So the x in the top would be replaced by 1, and we can divide out one of the x's in the denominator. So that would just leave us with 1 over x. In the second example here, notice we have a common divisor, or you can also think of it as a factor of x plus 2 in both the numerator and the denominator, right? So we could divide that out and be left with simply 2/3, okay? So this is what it means to have a rational expression in its simplest form. So let's go through a little more involved example. Here's a rational expression I'm giving to you, and I'm going to ask you to simplify and then also state any restrictions on the variable. So we'll talk about what does it mean to have a restriction, okay? So restriction is any value that makes the denominator equal to 0. Okay, so if we were to put a 0 in for either x or y, we would have division by 0, right? So we can't divide by 0, we'll have an undefined condition. So let's go ahead and simplify first using common divisors. So we actually have quite a bit we can simplify here. Let's start with the coefficients. Notice we have a 27 and a 9. So what can we divide out of both of those? Well, we could divide out a, whoops, I guess we're going to do the y's first. Okay, let's do that. We can divide both a y out of both the numerator and the denominator, okay? We could divide 3 x's, since we have x cubed in the top and x to the 4th in the bottom, we can divide 3 x's out of both the numerator and the denominator. So that leaves us with just x. And then 27 and 9, we could divide 27 by 9 and get 3, and then 1 for 9. So what do we have left there? In the top, all we have is a -3, and in the bottom, we have a 1x. So basically, we'll write our simplified form as -3 over x. Now, restrictions. When we state the restrictions, we want to go back to the original expression, because notice in the simplified expression, all we have is an x. So definitely that would give an expression. But in the original, we also had a y in the denominator. So that's why we go back to our original expression when we're looking at restrictions. So what would our restrictions be? Well, we kind of already talked about that. We don't want to have division by 0, so x cannot be equal to 0. or y cannot be equal to 0. Okay? So those would be our restrictions. So when we simplify all these problems that we're going to be working on today, the second step is to state any restrictions. What value would make the denominator equal to 0? Okay, let's look at some more examples here. 2x plus 1 divided by 6x squared plus 3x. Now, right off the bat, you say, oh, I don't know if there's anything I can divide. But the first step when you're simplifying is ask yourself, can I factor, right? Is there something I could factor out of these expressions? So let's look at that. 2x plus 1, nothing to factor there, nothing common between 2x and 1. But in the denominator, 6x squared plus 3x, we could factor out a 3 and an x. So let's do that. Okay, if we factor out a 3x, right, here's the 3x that we factored out, we're left with 2x plus 1. So now notice we have a common divisor. We can divide out, right, the 2x plus 1, and we're just simply left with 1 in the numerator and 3x in the denominator. Okay, so there's our simplified form. Now restrictions, okay? So state restrictions. Now, we said we want to do this from the original expression, but it's going to be easier for us to do it from the original expression, but in its factored form, right? So we're going to go back to this point before we simplified and find our restrictions. So we've got x's that occur in two places, right? We've got 3x and 2x plus 1. So the first one, let me turn my pen on here. So the first restriction comes from, let's go back to red here, comes from this factor, right? Specifically this x right here. So if we put 0 in for x, the whole denominator would become 0, okay? The second restriction, we can take this expression, 2x plus 1, and say that cannot be equal to 0. But really, we have an equation here that we can then use to solve for what values of x, right, would make it equal to 0. Okay, so this would be simple, right? Subtract 1 and divide by 2, and we wind up with negative 1/2, which means if we put a negative 1/2 in for x, this entire expression, 2x plus 1, would become 0, and therefore that would be our restriction, okay? So here's our answer. Simplifies to 1 over 3x, and our restrictions are x cannot be 0 or negative 1/2. Okay, so there was an example where we had to factor first before we could simplify. Let's do another one here, a couple practice ones. Let's see if you can do this in your paper. So I'll pause for just a second and then go ahead and work through it. Okay, so 60x cubed divided by 12x. Well, what can we divide out? Right? We could take the 60 and divide it or factor it into 5 and 12. So now we have 12 that we can divide out. And since we have x cubed in the top and x in the bottom, we can also factor out 1x. So let's go ahead and do that. We'll divide out the 12. We'll divide out one of the x's. That's going to leave us with x squared in the top. So notice everything in the bottom divides out. It's just going to leave us basically with 1, right, in the bottom, okay? So we don't need to put that 1 in the denominator. We would just write our simplified form as 5x squared, okay? Now, what about restrictions? Well, let's go back to our original form. Before we simplified, but when we still had it factored, right? And this x right here is what is going to give us our restriction. So since x is just multiplying the 12, we can't allow x to be equal to 0. So there's our restriction, right? 12 times 0 would give us 0 in the denominator. All right, let's try another one. N squared plus 6n plus 5 divided by n plus 1. Now, notice what kind of an expression do we have in the numerator here? It is a quadratic expression, right? So we need to factor it. So this will be good review. How do we factor a quadratic expression? Remember, use the x method. So we'll go ahead and factor that. And I'm not going to show all the steps, but if we factor that quadratic, right, we would have n plus 1 and n plus 5. All right, so let me just, for sake of a little review here, remind you how to factor here, right? If we put our, where's my pen here? Thought I just had my pen. Let's go back to red. So remember the method for factoring, we would put in the product of A and C in the top, so we'd have a 5, right? And then our B value in the bottom, okay? So what two numbers, if we multiply, give us 5, and if we add them together, give us 6. So this one's pretty easy, right? The only factors of 5 are 1 and 5. So if we multiply, right, that gives us 5. And if we add them together, that gives us 6. Okay, so that's where these factors come from here, n plus 1 and n plus 5. All right, so now we notice we have an n plus 1 that we can divide out. Let's go ahead and do that. And that just leaves us with n plus 5. Now, what do we need to do to find our restrictions? Well, we're going to go back to factored form before we simplified. So our restriction will be based on this expression in the bottom, n plus 1. Well, what would make the whole expression equal to 0? If we put a negative 1. Negative 1 plus 1 would give us 0. Okay, so there's an example of factoring with a quadratic. Let me pause and let you go ahead and do this one for a second. So factor both the numerator and the denominator here and see what you get. Okay, so the top, right, we can factor a 3 out. So we factor out our 3 and we're left with x minus 2. And the bottom is a quadratic that we can factor into x minus 4 and x plus, or x minus 2. So let me do that factoring here real quick for us. Get my pen back, set this up. Right here we have a 8, positive 8 in the top, and a negative 6 in the denominator. So what are the factors of 8 that would give us 6 if we add them? Well, 2 and 4, but they would both need to be negative, right, to give us the negative 6, okay? So that's where these factors come from here. X minus 2, x minus 4. All right, let's simplify. We can divide out the x minus 2's. We're left with 3 over x minus 4. But now we need to find the restrictions. So where do we look? We go back to our original expression, but in its factored form, right? And look in the denominator. So x minus 4 and x minus 2. The restrictions there would give us a positive 4 and a positive 2. If we put in 4 for x, this first expression becomes 0. If we put in 2 for x, the second expression becomes 0. All right, so we know what it means to simplify rational expressions. What does it look like if we multiply? So multiplying is really exactly the same. It's just that we have more places to look for where we can both divide out any common divisors or to look for restrictions, okay? So let's go ahead and factor the numerators and denominators. Well, there's really nothing much to factor here, so we can go ahead and start dividing things out. So the first thing we can do is divide 7 into both 7 and 21. So we're going to get 1 and 3 there. 12 and 24, right? We can divide 12 into each of those. So we'll get 1 in the numerator and 2 in the denominator. Now, how about our variables? We've got x to the 4th in the numerator and x in the denominator, so we can factor out one of those x's. That leaves us with x cubed. And we can factor out 4 of the y's, so that will leave us with 1 in the top and just 1 y in the bottom, in the denominator. All right, let's rewrite this, right? What do we have left? We've got a 1, but we don't really need to put that. We've got an x cubed, and we've got another 1 here. Okay, so we're just going to have x cubed in the top. In the bottom, we've got a 2, a y, and we've got a 3. So we can go ahead and multiply the 2 and the 3 together, and then that gives us 6y in the bottom, okay? So there's our final answer, x cubed over 6y. Now on to restrictions. So where do we look, right? We're going to go back to the original, and the top is really the same as the second line here, right? I didn't really change anything. So we've got a y here in the denominator that we're multiplying, and an x here. So if either x or y are 0, that would give us 0 in the denominator. So those will be our two restrictions. X equals 0, or it cannot be equal to 0, and y cannot be equal to 0. Okay, so there's an example of multiplying. Really the same thing as simplifying, just a few more places to look when we both simplify and state our restrictions. Let's try another one. Here we go. So multiplying two expressions. So again, if there's nothing obvious that we can divide out of both of these, then let's factor. Okay, let's see what we can factor here. So the only thing we can factor, well, 3x, nothing to factor there. 2x minus 1, nothing to factor, but the 8x minus 4, right, we can divide out a 4, okay, and leave us with 2x minus 1. And then 3x plus 6, we could factor out a 3, right, and that leaves us with x plus 2. Okay, where can we simplify now? So we have the 3's that we can divide out in the numerator for the first factor and the denominator for the second factor. And we can divide out the 2x minus 1 expressions. So what does that leave us? Well, we've got a x up here and a 4, and we've got an x plus 2 down here. So let's rewrite that. We have x times divided by 4 times x plus 2. Now, it's okay to leave this in factored form. Matter of fact, it's preferable that you do that, okay? But now let's go back to restrictions, okay? So we go back to our factored form before we simplify, right? We had two places where we had x, 2x minus 1 and x minus 2. So x minus 2, this would give us a restriction of negative 2. 2x minus 1, remember, let me show you how we got that. Let's go back to my pen here. 2x minus 1, we basically want to just set that, right? Oops, I'm sorry for my, whoops, minus 1 equals 0, right? So if we're actually not equal to 0, so we would add 1 to both sides. So we'd have 2x equals 1. And then we're going to divide by 2, right, to get the x by itself. So that's where the 1/2 comes from that we have down here in our restriction. Okay. All right, let's try another one, multiplying. Lots of factoring to do here. So we have 3 quadratics. And I'm not going to show all the details here for factoring, right? But we've got, this is a quadratic we can factor, this one's a quadratic, and this one's a quadratic. So let's go ahead and show that in their factored form. X squared minus 25 would factor of x plus 5 and x minus 5. X squared plus 6x plus 8 is going to factor into x plus 2 and x plus 4. The other quadratic will give us an x minus 4 and an x plus 2, and then nothing we can do with the x minus 5. That just comes down. All right, now where can we simplify? A couple things here, right? We can divide out the x minus 5s. We can divide out the x plus 2s. Tempting, right? We've got an x minus 4 and an x plus 4, but those are not the same, so we have to leave those. So our final answer would show the x plus 5 and x minus 4 in the top, right? These guys here, and then x plus 4 in the bottom. Now restrictions, we've actually got a lot of places to look for restrictions here. We have the first factor, right, x plus 2, so a negative 2 would make that 0. The next one is x plus 4, so a negative 4 would make that 0. And then the last one, x minus 5, so a positive 5 would make that 0. So we've got 3 restrictions, -2, -4, and +5. All right, let's see, let's do one more together and then I'll have you do a couple practice. So again, lots of factoring to do here. This is a quadratic. This is a quadratic that will factor. This we can factor out factor out an A. Okay. So here's what that would all look like, right? The first one gives us A minus 2 times A plus 2. The bottom one gives us A minus 1 times A plus 1. The bottom one here will factor out an A, it leaves us with A plus 2. So what can we divide out? Well, got a couple things, right? The A plus 2's divide out, the A plus 1's divide out. What does that leave us with? We've got an A minus 2 in the numerator and an A minus 1 times A in the denominator. So there's our simplified form. Now let's look at restrictions. So we would have a positive 1, right, for this first term. Let me get my pen back here. My red color. We get a positive 1 from this. We get a negative 1 from this factor. An A by itself will always give us 0, and then an A plus 2, right, gives us a -2. So a lot of restrictions here, right? We've got 4 different values that if we put them in for A, any one of those would make the denominator equal to 0. All right, let's try another one here, more factoring. This is a good lesson to review factoring here at the end of the year. Those of you that are going on to trig next year, being able to factor something is a really important skill to be able to have and not even really have to think about it. Okay, let's factor. So here's how all the factoring comes out, right? We've got a lot of, every one of these actually can factor, except for one actually, the last denominator doesn't factor. But 2x plus 12, we factor out a 2. 2x minus 6, we can also factor out a 2. 3x minus 9, we factor out our 3, and then nothing to factor here with the 3x plus 8. So what can we divide out? Well, there's really only one thing we can divide out, right? The x minus 3. So what do we have left? We've got 2 times 2, which is going to give us 4, and then an x plus 6, and then 3 times 3x plus 8. So here's what that looks like in its simplified form. Now restrictions. Well, let's go back to our factored form here. We've got an x minus 3, so that'll give us a restriction of +3. And then 3x plus 8, let's set that equal to 0. Get my pen back here. So 3x plus 8, we set that equal to 0, or not equal to 0, really, in terms of our restrictions, right? So 3x plus 8, not equal to 0. So how would we solve, right? We would subtract 8 from both sides. So we have 3x cannot be equal to -8. And then, of course, the last step is divide by 3. So we wind up with x cannot be equal to -8 over 3, right? Which is where that restriction comes from right here. Okay. All right, last part of the lesson here, how do we divide and simplify rational expressions? Well, how do we divide by fractions? You guys know this. We divide a fraction by turning it into a multiplication, right? We're going to divide by the reciprocal, and then we'll simplify and state any restrictions. So let's start with some simple examples here of just integers, and then we'll put in some variables. So the first step is to rewrite this as a multiplication problem. So it would be 5 over 16 times 8 over 15, right? So we're just going to take this and rewrite it down here as the reciprocal, okay? So now it's a multiplication problem. We do just like we did in the previous part of the lesson. Where are the common divisors that we can divide out? So let's do that. We've got a 5 and a 15. So 5 divides into each of those, once in the top and 3 times in the bottom. We have 8 and 16. 8 divides in once, 8 divides in twice. So what do we have left here? We've got, go back to my highlighter. We have 1 times 1 in the top and 2 times 3 in the bottom. So this whole thing just simplifies to 1/6. Now, no restrictions here because there's no variables in the denominator. We don't have to worry about restrictions, okay? All right, let's look at another one with some variables in here now. So same thing, first step is to rewrite it as a multiplication problem by multiplying by the reciprocal. So all we're going to do is take the 9x cubed divided by 16y and flip it around, its reciprocal, and now begin to simplify. Okay, so lots of things to simplify here, right? The 3x we can divide into the top and the bottom, right? And we're going to be left with 3x squared, right? We divided out a 3 and then divided out an x, kind of in the same step there. The other 16y and 4y squared, we can divide a 4y out of that. So that leaves us with just 4 and 4y, I'm sorry, just y in the bottom. So what do we have left? We've got 1 times 4, and then we've got y times 3x squared. So let's multiply those together and simplify. So 4 over 3x squared y. Now restrictions. Well, remember, we were going to go back before we simplified, but basically we have a y and an x in the denominator. So x and y could not be equal to 0. Okay. All right, well, let's do one more example here. This is already in factored form, right? So we don't have to factor it, but we do need to rewrite it as multiplying by the reciprocal. So let's go ahead and do that. We just take this whole thing here, right? And then write it as the reciprocal down below. And then where can we simplify? Well, I see a couple things, right? X minus 4's divide out, X minus 2's divide out. What does that leave us with? We've got a 7x minus 5, 3x plus 2, and a 5. Okay. Now, restrictions. The restriction comes right here from 3x plus 2. So if we set that equal to 0, right, we would subtract 2 and divide by 3. But here's one other place we need to look for restrictions, right? We want to go back to the original problem and see where else did we have a variable in the denominator. So notice in both of these, before we multiplied by the reciprocal, we had an x minus 2 in the denominator. So we need to include that in our restrictions. So x minus 2, the restriction there would be x cannot be equal to a positive 2. We also had a 7x minus 5 in the original problem. So if we add 5 and divide by 7, that's going to give us a 5/7. So the one extra thing we need to do with division problems is when we find the restrictions to go back and look at the original problem before we took the reciprocal and see what is in the denominator that might create a restriction for us, okay? Oh, and we had one more, right? We had the x minus 4 before we simplified, okay? So lots of restrictions, lots of places to look for here. All right, let's let you try a couple of these and then we'll wrap up this lesson. So here's one with just integers. Go ahead and rewrite it as a multiplication and then simplify. Okay, hopefully you had a chance to do this. So let's rewrite it as a multiplication with the reciprocal. And now we've got a couple things, right? We can divide 6's out of the top and the bottom and an 11 out of top and bottom. So let's do that. 6 goes into 6 once, 6 goes into 18 3 times, 11 goes into 22 twice, and 11 goes into 11 once. So what do we have left? We just have our 2 and a 3, right? Don't have to worry about multiplying by 1, okay? So there's our final answer. No restrictions, no variables in the denominator. Let's have you try another one here. Okay, first step, rewrite it as a multiplication of by the reciprocal. And now where can we simplify? Actually, lots of things we can do here, right? Let's begin. First, we can divide a 5 out of both the 5 and the 20. That is still going to leave us with an x cubed in the bottom here. Notice no x's in the top. We can divide a 8y squared. So that'll leave us with 3 and just 1 in the bottom. So I'm kind of doing the integer and the variable together in one step here. So what do we have left? We've got a 3 here and a 4x cubed in the denominator. So here's our final simplified form. Now restrictions, where do we look? Well, the original problem, right? We had y's in the denominator, but then we also, after we wrote the reciprocal, had an x in the denominator. So we need restrictions for both the x and the y. So neither x or y can be equal to 0. All right, last one where we'll have to do a little factoring here. This kind of has everything included in it. So notice I factored the 3 out of the 3x minus 15. And then we took the reciprocal of this, right, down here. And as I did that, the 5x minus 25, I factored out a 5. All right, so now we can divide out the x minus 5. We can divide out a 2x. That's going to leave with 2x in the bottom, right? Divide by 2 and divide by an x. So what do we have left? We just have the 3 and the 2x and the 5. So that's going to leave us with 3 over 10x. Now restrictions. Well, where do we look? We can go back to our factored form before we simplified, right? So we have an x here, and then we have this x minus 5. So we would have 0 and negative 5 as our restrictions. We also had this x in the numerator or denominator originally, right? But that's going to give us the same restriction as the other x. So that's covered here with the 0 that we have. Okay, so that's it. Rational expressions. We now know how to simplify, including finding any restrictions, and we know how to multiply and divide rational expressions. Okay, so there is a worksheet that goes along with this posted in Google Classroom. It's one where you'll have to do the work on your own piece of paper and then take a picture and submit that, but you guys are getting pretty good at that at this point. So work through those. You guys will be experts at simplifying rational expressions. All right, thanks.